So what I meant by that is let's try to get on track so that when we're ready to do the 8-9 guide, we're all paying attention and listening to the lesson. Okay, so for the first part, we're going to be working with polynomial functions. So for polynomial functions, polynomial functions f and g of x. What we're going to be doing in this section is we're going to be adding, subtracting, and multiplying polynomial functions. And if you can add, subtract, and multiply numbers and terms, and that's pretty much what we're going to be doing in this section. So the sum can be found by simply taking f of x, whatever it is, and adding it to g of x. Okay, so really the first part is just going to be like adding and subtracting like terms. There's 3 different notations for it, and you have to be prepared for all 3 on a test. So f of x plus g of x can be written also as f plus g if we get lazy and leave out the x. Okay, and the next one is the most confusing to people. It's f plus g of x. But it means the exact same thing as the ones above. Okay, it doesn't mean f plus g times x. I'll get people on the test doing it. Okay, it still means f plus g of x. And the difference can be found by just subtracting it. So f of x subtract g of x, or f subtract g, or f subtract g of x. The product is f of x times g of x, or f times g, or f times g of x. So 3 different ways of writing the exact same question for each part. Okay. So let's just do a quick example. Example given. The function f of x is equal to 3x squared minus 4x plus 5. And g of x is the function 6 minus 7x. Determine so we're going to reach back to our first guide, and if I ask something like this, what am I asking? Yep. Okay, so this tells me which function to use, right? And this tells me what to replace with the x. So f at 0 is equal to substituting 0 into the function, doing our proper BEDMAS, I get 5 as an answer. Make sense? Okay. So if I ask this question, yeah, it's probably a good idea. What do you think that means? Look at. And then do what with the answers? Exactly. Okay, so remember this is another way of writing that, which is another way of writing that. So it might be useful for some people till they get used to it, so just to rewrite it as f at -1 subtract g at -1. Okay, so now it's just f at -1. I put -1 in where to the f function, everywhere I see an x. Subtract off, and make sure you put this next part in brackets, right, whenever you're subtracting. Subtracting off g at -1, which is, now it's just a matter of simplifying correctly. So -1 squared is 1 times 3 is 3, plus 4 plus 5, minus 6 plus 7, which is 12, minus 13, which is -1. And just make sure that I've done all my math correctly. Pretty straightforward stuff. Okay, so those are adding, or we've only done really subtracting, two functions at particular values. If I want to add, subtract, or multiply the functions, then I'm answering questions like this. What is f plus g? So f plus g is a lazy way of writing f of x plus g of x. But simply just do exactly what it says. Take your f function, which I forget what it was, 3x squared minus 4x plus 5. No, it's minus, right? And add it to your g function, which is, so now it's just a matter of collecting like terms. 3x squared negative 11x plus 11. Coming? Straightforward stuff? Okay. So g subtract f of x. So g subtract f of x means g of x subtract f of x. G of x was 6 minus 7x. Subtract, make sure you put the next part in brackets. If you don't, it'll be wrong. Now it's just a matter of distributing the negative through and then collecting the like terms. Did I give you the stack sheet? Did you rewrite this already? I didn't write it yet? Can you take the stack? Okay, so collecting like terms. And when you collect your like terms, put them in standard form. So do your squareds first, then your x term, and then your constant term. Which is a matter of adding or subtracting, whatever you need to do, and then collecting the like terms. Probably don't need me to do this example, but we'll just do it just for mind. How to do it, f times g. So just take the two functions and multiply them together. So the first function multiplied by the second. So now it's just a matter of distributing. So 3x squared would be 18x squared times that would be negative 27x cubed. No, I said negative 27, I meant negative 21. Then this times that is negative 24x. This times that is positive 28x squared. And then that times that is 30. And that times that is negative 35x. Now it's just a matter of collecting all the like terms together. So I have negative 21x cubed, the x squareds. Would that be 46? Correct me if I'm wrong. And then the x's would be negative 59. and then the constant. Okay. Any questions? So adding, subtracting, and multiplying polynomial functions is pretty straightforward. You just add, subtract, multiply the functions, collect like terms. The reason we can do that easily is because polynomial functions, what's the domain of every polynomial function? Everybody remember that? Yep. Here. Right, well, any real number, right? Okay, so I can always add and subtract because the x's are going to match. When we get into a discrete function, it becomes a little bit different. Okay. To know the difference, we have to know what discrete functions are. Does anybody know what a discrete function is? Anybody? Yeah. Awesome. Okay, so the function is just made up of individual points. You don't connect the points, they're just a bunch of points on a graph. Okay? And then when you're adding, subtracting, and multiplying discrete functions, you can only add, subtract, and multiply the y values where the x values match up. Okay? So the y values can be added, subtracted, multiplied, only when the functions have common x values. Okay, so we'll do an example of working with discrete functions. So given f of x is the set of points -2 and 0, -1 and 3, 0 and 4, and 2 and 7, and G this is -2, so -2. My pen's already not whacked. Hopefully it works. -2, -4, -1, and -1, 0 and 5, and 3 and 8. Okay, so those two functions are discrete functions because they're just points, and if I was to ask you to graph them, you would just plot the points, you wouldn't join them together. Okay? So example, given blah, 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 determine this. So what would the value of f at 0 be? Sure. 4. Okay. So this is asking, using the f function, you're figuring out when x is 0, what's the value of y, and it's already given to you. Right? So with discrete functions, the answer is already given to you. If it was a polynomial function, you'd have to plug the 0 into the polynomial and get your answer. But for these ones, the answer is given to you. Okay. So when I ask something like this, f minus g of x at -2. So f minus g at -2 means f at -2 subtract g at -2. So f at -2, f at -2 is equal to 0. Subtract g at -2, g at -2 is equal to -4. Simplifying, that looks up to be straightforward stuff. Okay, so now we'll get into adding them. So when you're adding discrete functions, you can only add the points that have the same x coordinate. Okay, so the x coordinate stays the same, and then you add the y coordinates together. So my first value is -2. I make sure that g has a -2. It does. So then my first point on my function becomes -2. And since I'm adding the functions, I add the y values. 0 added to -4 is -4. Then I look at my next guy, which is -1. I make sure there's a -1 in the g function. There is. So the next point would be -1, and I'm adding 3 and -1, which gives me 2. 0 and 0 match up. I add 4 and 5, which gives me 9. Then 2, and this guy doesn't have a 2, so I can't add. So I'm done with the adding of the function. I can only add those 3 together, and those are the 3 points that make up the function f plus g. Make sense? So just do whatever the question's asking you. So if it asks you f times g, then you keep the x value the same, and you just multiply the y values. So -2 and 0 times -4 is 0. -1 and 3 times -1 is -3. 0 and 4 times 5 is 4. So those would be the 3 points that make up the function f times. We good? So the last thing you're going to be responsible for adding, subtracting, and multiplying functions is when you're given the graph of the function and you want to either add, subtract, or multiply, depending on what the question's being asked. So there we go. So that becomes a little bit easier for us to see. Okay, so this is my f function, and this is my g function, and I want to figure out what f plus g is. So let's figure out, first of all, what type of function I'm going to get when I add f and g together. So what types of functions are f and g? What are they? Linear. When I add two linear functions together, what am I going to get? What type of function when I add them? A linear function. How many points do I need to make up a linear function? How many points do I make to make a straight line? Okay. So all I need to do is to figure out a common x value and then add their y values together to figure out the point on my new function. Make sense? So I'm doing the exact same thing I did here, right? Back here. But here they gave you the points. Here I'm going to select the points. Okay. So if I choose this value of 1 here, then both of them at the same time are equal to 1. So then what would my new point be? If I'm adding the two values of 1 and 1, it would give me 1 plus 1. Here. So I take another one. It doesn't really matter where it is. I can take this guy, this x value here, which is -1. So -1, this guy here is 5. This guy down here is -5. What is 5 and -5 added together? 0. Okay. Does that make sense to what I'm doing? Okay. So now I have enough. And you guys would use a ruler. I don't have one. That's your function of f plus. Good luck. Okay. Okay. Let's do f subtract g. So this is a little bit different, right? Because I'm taking f, which is a quadratic, and I'm subtracting off g, which is a linear function. When I subtract a quadratic, when I subtract a linear function from a quadratic, what type of answer am I going to get? What's it going to be? Yep, it's quadratic. So you're going to need more than 2 points to make a quadratic, because you've got to make that U-shaped curve, right? So do as many points as you think you need to do in order to make the curve. You guys know what I'm talking about? Okay, so then I'm subtracting them now. So right here, oops, I'm not going to color it because I'm going to use green for my thing. So right here, f and g have the same value. They're both at 3. So if I take 3, subtract 3, I'm going to get 0, right? Yep, yep. You're going to the office first, right? Okay. Right here, at this value right here, again, they're the same value. So when you subtract off the same value, you're going to get 0. So 0 right there. And then we'll find one other point in the middle. Here, g is 0. Here, f is -5. So I want to do -5 subtract 0, which is -5. I get that. That's probably enough information to graph this guy. And that would be f subtract. If you need to do more points, do more points. Okay? But you're just basically picking a common x value, looking at the two answers, and then adding them or subtracting them or dividing whatever the question happens to be. Okay? If I asked you to do f times g, what type of function would you get? So if I take a quadratic, yep. Yeah, cubic. So you might have to do a little bit more points to figure out where it adds up. Okay? Any questions? Okay, so that's it. Next week, because of the